Good morning, friends. We have discussed in the previous session about the shear force and bending moment diagram, specifically for the simply supported beam. So now onwards we are discussing about how the shear force and bending moment diagram changes with the different kinds of loading for cantilever beam. So now this series 2 is based on for cantilever beam. After this session, we will able to do the following: understand the concept of shear force, concept of bending moment, and able to plot shear force diagram and bending moment diagram for cantilever beams. Now let us revise that what is shear force, what is bending moment. So when a beam is loaded by forces or couples, stresses and strains are created throughout the interior of the beam. These internal quantities are referred as shear force and bending moment. A typical figure shown over here, please see this PPT carefully. The beam with application of external loading. When we take a section over here, at this junction, my section will be divided into two parts, left part as well as the right part. So for left part, there is a stresses, internal stresses are generated. These stresses are referred as shear force and bending moment. What is shear force? Shear force is the algebraic sum of all the vertical forces acting to the left or right of a section along the span of the beam, while the bending moment is the algebraic sum of all the moment of forces to the left or right of the section. The typical sign conventions which is shown over here, which we have been adopted throughout the series 1, 2 and 3, means for all kinds of beam, for shear force is concerned, section left upward is treated as positive shear force, while section left downward is treated as negative shear force. While for bending moment, section left clockwise moment is treated as positive bending moment, and this bending moment is referred as sagging bending moment, while section left anti-clockwise bending moment is treated as negative bending moment. So with this we are going ahead. These are the steps that we have to follow to plot shear force and bending moment diagram. That is to determine the shear force and bending moment at every section of a beam. We have to follow this procedure. That is the step number 1 is to find out the reactions. Then we have to cut the beam at a certain cross sections and draw the free body diagram of one piece of the beam, either left part or the right part. Step 3, set up the equations. Number 4, solve the shear force and bending moment at that cross sections, and number 5 is the plotting of shear force and bending moment diagrams. Now let us start with a first number of problem. The given beam over here is a cantilever beam. The beam whose one end is fixed, other end is free, is known as cantilever beam. For this particular beam subjected to a only single point load at the tip of a beam, and our intention is to draw the shear force and bending moment diagram. That is the variation of shear force along the length of beam as well as the variation of bending moment is along the length of the beam. Now here step number 1 is to find out the support reactions. We have to find out the support reactions by using 3 equilibrium conditions. If we use this number 1, sigma h is equal to 0, as there is no external horizontal forces acting on this particular system of bodies, means RAH is equal to 0. Applying sigma V is equal to 0, total upward force is RAV is equal to total downward force W. So VHU RAV is equal to W. And the third equation, sigma M is equal to 0, that is to take a moment over here is equated with the 0, and here we have assumed the sign convention of moment MA is of anti-clockwise, means minus MA plus W into L is equal to 0, and VHU MA is equal to W into L, kilonewton into meter, that is the unit of moment. The positive sign of MA signifies that the assumed direction is right, that is we assumed bending moment or a moment over here is of anti-clockwise is right. Now next step is to plot shear force and bending moment diagram. Now here is the diagram. Let us be understood by using this tabletop. Now the given beam is of cantilever beam, subjected to a point load W. Length is L is given to us. Now we have two options. Either we want to use the various rules that we have adopted, we have to be used in the previous cases in the series 1, or should we take a section and then we will plot. So now let us use our original approach. By taking a section, we are going to plot the shear force diagram. This is our baseline. All the positive values are plotted above the baseline, all the negative values are plotted below the baseline. We know the various reaction. This is RAV, W, MA is nothing but W into L, and the horizontal component is 0. Let us take a section over here and let us plot the free body diagram. Now it can be visualized over here. Within this section only one force is acting, that is RAV, that is W. So if this is a support A, then shear force at A is equal to plus W. So within the range of X there is no force is acting, hence the shear force is W throughout the section X. So if we will plot over here, if we take here up to X, the value is of W till there is no load is acting throughout. So if we take a section over here XX, even though this remains W throughout till the point or section B will be there. And about the sign convention, section left upward treated as positive, so this is positive. So this is our very simple shear force diagram. This diagram stated us that the value of shear force is W throughout the length of the beam. It remains constant as there is no load is acting. So if we will apply our basic rule for the plotting of shear force diagram, Then support reaction itself gives us the value of shear force W. Between A and B, no load is acting. Variation of shear force, which has been given as horizontal straight line, and then the W itself, sudden change when there is a load is applied. So this is the shear force diagram, which is shown over here in this PPT. Carefully visualize this PPT also. Next, our intention is to plot bending moment diagram. This is the bending moment diagram. Now, how this diagram has been plotted, let us see using this tally top. This is our baseline. All the positive values are above baseline, all the negative values below baseline. Now, taking a section XX over here, distance x from A. Then, shear force at XX is equal to, first, very much important, WL. It is a direct moment acting. Then section left anti-clockwise treated as negative minus WL. Section left create clockwise, so it is plus W into X. So you just visualize over here, if you take a W as a common term, minus L plus X, simple variation of term X. So if we put the value X is equal to 0, if we put the value X is equal to 0, then shear force at A is equal to minus WL. So at this point it is of WL with minus sign. Now if we take X is equal to 0.5L, 0.5L means at the center of a beam over here, what is the variation? Then shear force at center is equal to W minus L plus 0.5L, and we will achieve as it is minus 0.5 WL. So here we achieve 0.5 WL. If we take X is equal to L, that is at B, then SF at B is equal to W bracket minus L plus L, and this comes to be 0. So just visualize over here, by joining all these points we will achieve straight line with negative sign. This is my straight line. Same thing we can see in the PPT also. We can derive the same diagrams by taking a section on the right side. So how it will behave if we take a section from the right side? Should our steps will be reduced? This we check over here. The given beam is of cantilever, W is over here, length is L. If we take a section over here, XX from B, then our free body diagram is of this kind. Then shear force XX is equal to, obviously only one load is acting throughout the beam, it is of W. about the sign convention. Then just visualize section XX, right side downward, it is treated as positive, so this is of plus W. So if we take a section from the right side and if we proceed further, then plus W, no load throughout, it is horizontal straight line relationship, and as we know this one, reactions W plus sign. This is my shear force diagram. So just see, an easy equations will be achieved if we take from the right side. Now let us take the bending moment at XX is equal to W into X. Section right clockwise. So this is section right clockwise. This is created hogging nature of bending moment treated as negative minus Wx. This is equation of linear equation. So if we will put x is equal to 0, bending moment at B is equal to 0. But if we put x is equal to L, bending moment at B is equal to W into L with the negative sign. And if we will plot this diagram, 0 over here, WL is over here, joining this line, so inclined straight line. So if we will compare both these equations over here from the left and right, you just visualize these equations becomes more simpler if we will take a section from the right side. So now onwards, when we will solve the problems, we are taking a section from the right side for a cantilever beam, so that our equation will be simplified and we can plot the SF and BM diagram very easily. So now from this first problem, it is clearly we can plot SF and BM diagram for the cantilever beam subjected to the point load.